All right, everyone, we're ready for the next session. We've got Richard Peters. He's a director with the Berkeley Research Group within the Technology Advisory. Test. Is that better? Got to get close. Okay. All right, guys, we're ready for the next session. We've got Richard Peters. He's a director with the Research Berkeley Group within the Technology Advisory practice. He's specializing in information security and compliance. And he brings over 15 years of experience managing and performing and delivering IT security solutions. His experience includes technology risk management, IT auditing, IT security assessments, internal auditing, attack and pen testing services, and analysis in domestic and global entities across the energy, technology, financial, and manufacturing industries. We've also got Matthew Roth. He's a computer information security systems undergraduate student at University of Houston Clear Lake. He's a former intern of Berkeley Research Group. He's currently a research analyst or research assistant at University of Houston Clear Lake. And his skills include pen testing, vulnerability analysis, and software development. So welcome them to talk about Parasyste.
All right, I'll stand over here. Can you guys hear me okay? All right, well, welcome everybody. Thanks for letting us be here. Glad we got a crowded room. We're going to show you a project we've been working on. We're open sourcing this, so we're actually kind of soliciting some help. Does anybody have one of these devices? No? So it's called a USB Armory. Has anybody heard of them? Good. Glad y'all don't have these things. So to me, these are the coolest things. So Quincy and I do lots of different things, and he's going to have a talk later on. We're talking about appliances and all, but I keep getting smaller and smaller. So this is actually a full-blown Linux computer. I'll give you the specs in a little bit. It's an open source hardware design. It's an open source software. You can run a full-blown Linux distribution on this. So Kali, Debian, Ubuntu. It's got, well, I'll go through the specs. But the purpose of this is whatever you want it to be, right? So they talk about, you can put it in a kiosk, and then you can use a secure session there. Maybe you use your Bitcoin wallet on here. Maybe you use it for a Tor connection from your PC. So there's all these different ideas. So Parasyste's going to be our idea for this. And we'll talk about what we came up with. So we do a lot of penetration testing. We get permission to hack. So I thought, man, wouldn't it be cool if I could stick this into a host, have it kind of auto do some stuff, and then just connect back to my lab, and I use it as a parasitic host to the PC that I plug it into. So we just ran through and said, okay, I want to have persistence, right? I want to just plug it in and leave and kind of have it do its thing. I want it to do a reverse shell SSH connection back to my lab. While I'm at it, why don't we harvest some host information, try to scrape memory, let's dump some password hashes, let's just do whatever you can do, plug it into a host. And maybe do some autonomous stuff so that if maybe SSH is blocked outbound, why don't we have some autonomous stuff that might do try to tunnel through DNS or ICMP or those types of things. You may be thinking, does anybody have one of those devices? The rubber duckies and all? So if you've kind of paid attention to this stuff, so the rubber ducky has been around for a while, and then the land turtle is actually something kind of brand new, and it kind of sucked because we put in we were like, we're going to save this for our Houston home, right? We're going to announce it here. It'll be so cool. And it was like 2 weeks later, land turtle came out. And But then we started looking at it and decided that it's still a little bit different. So we still think we're okay. So just to go over the differences in hardware, and probably hard to see because it's a little bit small, but so the US Armory, we've got a ARM processor, an A8, 800 megahertz processor. You've got actually 512 megs of RAM, which is a fair amount of RAM. Micro SD, it's got all, you can read about the goodies on it. If you talk about the land turtle and the rubber ducky, very, very low scale power from a CPU perspective, very, very low storage. They do have micro SD on the rubber ducky. And I'll tell you a little bit about So this one's $130. So it's the most expensive of the three. I think the land turtle is $50, and I don't remember how much the rubber ducky is. Okay, so 30, 50, and then we're showing you the expensive Cadillac. So it's got more CPU. So here's why we think this is a better platform to build from. Obviously more CPU, more memory. We like power. That's an easy one. Full Linux distro. So depending upon what you want to run or what you like to run, you can put that on there. So Kali 2.0 fully runs on this. We're running Debian for what we do. It really doesn't matter, right? It's Linux. Ubuntu, Arch, and Void. So this is I think a big key to how this is different than those other devices, the land turtle and the rubber duck. So hence the name, and Parasyste, right? Spelled properly wasn't available, so we got to be all kind of leaf security, so we spelled it S-Y-T. So it's Parasyste, but we're a parasitic host. We sit behind the host and not in front, and I'll kind of explain that. So in our case, we're doing this, right? I just plug it in. I go through the host out to the local network or out to my lab. Whereas the land turtle, it's different, right? You have to kind of plug it into the network on its own, and then it kind of plugs into the host. So in this scenario, right, it's getting an IP address. I mean, maybe you can do bridge stuff. I don't really know. I bought one too, but I haven't really played with it. But I'm assuming there's a MAC address associated with that. So if you're in an environment with maybe MAC protection, perhaps that may get blocked. It's just a little different scenario. So in our case, when I'm a parasite to the host, I actually take the persona of the PC. So the attacks that I do on the local network become the host IP address, the host MAC address. So it would appear, right, if you're really monitoring that, that it's your desktop PC, right, that's attacking the network that's there. And hopefully we're stealthy and you're not monitoring, so we'll make all kinds of assumptions there. So this does, and some of those other devices do it as well. They do USB emulation, whereas the other devices, they'll just do HID emulation. So essentially they appear as a keyboard to the PC. This actually does HID. We can do Ethernet, and actually two different types of Ethernet. The CDC makes more of the Linux side of it, and RNDIS. I don't even know that I know what that stands for. All right, test. So that's kind of the Windows version of the Ethernet. And then the last part of that is storage. So it's like a USB storage device, it's a USB Ethernet device, and it's a HID that we could present as a keyboard. So all those are capable in this device. So essentially, right, we have a full Linux PC that we can stick on our target network on the host, to use that host for the network to further compromise the environment, in addition to perhaps harvesting a bit of information on the host. Said most of this. If you want to purchase one of these things, just search for USB Armory. That's probably all you have to do. There's several vendors that sell them. It's $130 for the device, and then they have some connectors, all the stuff you add to it. So plan on spending about $150. Open source hardware, they fully print the designs for this thing. So I mean, if you're into printing circuit boards, you can do all that. USB powered. Micro SD, you do have to buy a separate SD card if you want additional memory. So I've got a 32 gig. I pass this around, but you can never get back some of this stuff. So we thought, right, so this is going to be easy, right? Emulation's not new. We'll do all this emulation stuff. I'll just enable internet connection sharing on the host PC. We'll do that somehow, and then I'm going to set up this reverse shell that we use all day, every day for our standard pen test stuff. So that's what we thought. And I'm like, okay, this will be easy. We'll just knock this out in a couple weeks, and we'll be ready well before this event today. So reality was this, I wouldn't say it's hard, but it was very time consuming. So all of a sudden we got into all this stuff you never think about when you have this, what you think's a clever idea. Vids and PIDs and kernel and user land and system land. And it became a bit of a chore to get this thing done. So this was, kind of last week. It's like, hey, it's all working. And then we find all these other things we want to do, and that's where we're going to maybe look to you guys if you're excited about this. There's some things we don't maybe know how to do better, so we'll look to you and maybe PowerShell experts to do some additional stuff. So we'll get into a bit of that. But we got it working, right? So yay. So we have the HID working, right? So we can plug it in. It looks like a keyboard. It types on your computer. We have the RNDIS, so we focused on Windows. So right now I didn't really build anything for the CDC. So I'm going for the masses, right? I expect that most of the time you're running a Windows PC. USB's not completely disabled. So that's all working. Storage, that wasn't too bad. I figured that out pretty quick. So we present a 256 meg storage device. It just looks like another USB storage device. All that's working fine. We had to do strings to HID. So essentially we have to send our commands through the HID to the device so that what we want it to type to the PC gets presented. So even down to opening the flying Windows key and opening up the run menu and doing those types of things, which is all similar to what the rubber ducky and those things do. We did get internet connection sharing turned on. We basically do that through PowerShell. So that wasn't too bad. So we've got the internet connection then. So we plug it in, it does its thing, recognizes it. We get an internet connection through the host, assuming SSH works outbound, then we get the reverse tunnel work. So we use in our daily pen test stuff, we use the reverse tunnel a lot. So that was kind of the easy part. In my case, I actually send this back to Amazon. So from the Amazon, then I reverse shell back to the device through the network. And so what we're going to do today is we're going to kind of share just the learning process through what we did. Kind of just to tell you those things. We're not going to get deep down in the code because you wouldn't be able to see it, but we will kind of tell you those things in case you're building your own gadgets or doing things. We want to kind of share that learning experience and kind of show you where we got. So Matthew's going to talk about the gadget part.
Thank you, Richard. So, like Richard mentioned, my name is Matthew Roth. I helped out on this project when I was an intern at Berkeley Research Group, and today I'm going to dive a little bit into the technical sort of meat and potatoes that really makes this whole thing work. And the key that brought all this together is a part of the kernel subsystem called USB gadgets. What that does is it lets your device act like a USB device, whether it's a flash drive, it's an Ethernet adapter, or maybe it's a keyboard. That was essential to this whole project. And here's a little bit about it here. So our armory will become, for all intents and purposes, a USB peripheral. There will be no distinction to the host that we're not an actual keyboard, that we're kind of a rogue device. And you'll see the last point here. It says we can create and define our gadgets from userland. That is essential because when we're using this thing, it's deployed on site. It can, in real time, without shutting down, reconfigure itself, bring up new gadgets, bring down old gadgets. Maybe we want a different type of keyboard. We want to change the vid and PID so it's recognized as something else. Maybe if they're filtering, maybe we want to switch to CDC to RNDIS or vice versa. We can do all that in real time remotely because of the flexibility we have from the USB gadget system. Now, this next slide is a quick history of this USB gadgets. First came out in 2003, so that was great. You could do everything from userland, but it was single purpose. So you had your HID device, you had your Ethernet device, or you had like a flash drive, but that was it. You picked one, you didn't do much customizing, and that was it. Obviously, like you saw, Parasyste can be 3, 4, 5 things at once. So that's not quite where we needed to be. In 2008, a new thing came out called USB composite gadgets. And if you plug a modern USB device in now, you'll see that a lot because it's used pretty frequently. Composite gadgets lets you, like the name implies, basically composite these single-purpose gadgets, your HID, your storage, into one composite gadget. And the way Windows handles that is it was surprisingly friendly. It uses something called a USB parent driver, and it parses into the gadget, and it'll find the individual functions. It'll say, here we have HID, here we have Ethernet, and then it'll pass those off and find the correct driver for each function. So it was pretty much plug-and-play functionality then. And so that was pretty much where we wanted to be. But now, in 2010, came out ConfigFS. And there were some improvements there. So we already had the ability to composite gadgets into one multifunction gadget, but now with ConfigFS, you have complete control over the endpoints, the descriptors, the way everything's handled internally, and that's where we get the incredible degree of customizability and flexibility for the devices that we are trying to emulate with the Armory. Well, this is a little bit about how ConfigFS actually works. At its core, ConfigFS is a file system. You mount it, you spawn and build your files inside of it, and that's what actually defines your device. Again, the key thing here is, of course, it handles with the USB device controller, so there is kernel interaction there, but we can do all this from user space, which is terrific. You have to mount it and you write into it, and I will show a little bit about how that works on the next slide. So this isn't all the commands to use to build our device. This is a little sliver of our script. You'll see the first line is key. We do actually have to mount mount.t configFS. So you'll see that configFS is actually the file system type that we're using. We always mount under /config, so we always know where it's at, but you can mount wherever you want. And once that's done, it's actually going to build that folder called USB Gadget in there. Inside USB Gadget are going to be all of your gadgets. So we call ours Parasyste. So we make the Parasyste directory inside there. So then, once you do that, it'll actually automatically populate all the different fields and folders that you're going to have to move into and write into. So the next thing here is for each function we want to have, we make a directory for it. So we have function /rndis, HID, and mass storage. And then once you make those functions, it'll create files in there for each setting that you're going to need to configure for that device. And the way you configure them is really easy. You go in there and whatever setting you want to put in the file, we just use echo setting, redirect into the file, and it's really straightforward. Lastly, to actually get this thing up and running, this last line here, you'll see echo CIHDRC is the name of the USB device controller on the Armory. If you try and port to different hardware, the name will be a little bit different, but there's a way you can do a directory listing of like /sys/UDC, and you'll see what the name is. And then we write the name of that into the file called UDC. Once that's done, the system is going to try and bind your gadget to that interface. So CIHDRC is the USB port on the Armory. And if it has issues, it'll tell you. If it succeeds, it'll also tell you. So it's fairly verbose, which helps. But from that point forward, your gadget is live, up and running. So here's just a few little screenshots here. Right here, you'll see that second listing under HID keyboard device. That was us. You'll see at the bottom of the network adapters here, RNDIS number 2. That's also us. Like Richard said, we used RNDIS because it's more Windows friendly. Of course, CDC Ethernet works everywhere but Windows. You come to Windows and we had to use their thing. So that's how it is. And then here, under disk management, we are seeing the flash drive that we're presenting to the system here, 255 megs, and we're presenting it as FAT, but you can use whatever file system you want. What happens is our script creates an ISO file, and that's what they call the backing storage for our flash drive. And you can build whatever kind of file systems you want in that file. And even should the need arise, you can actually unmount the flash drive with Parasyste, make whatever changes you need to it, and then remount it, and then all the files on the flash drive will be different. The key is don't change the files on the flash drive from the Parasyste side, because USB is very master guest oriented. So if you plug a flash drive into a computer, it's going to assume that nothing's going to change unless it initiates the change. So if you try and make changes from the device side, it's going to throw things for quite a loop. So don't do that, and you should be fine. So there's a little checkpoint of where we are so far and what I've just covered. And next is internet connection sharing. This is really important for our on-site work, because we want this thing to reach out. For example, we would use Richard's command and control server that's on Amazon. So this thing needs to be able to get out of its environment to the internet. And the way we do that is basically we force the host to share its internet connection with our RNDIS adapter. And the way we do that is, this is a little bit about ICS. Basically, we'll go in and we'll find their adapter that they're using for internet access. Probably going to be, a LAN or any Ethernet adapter, sometimes wireless. And we're going to do this all through PowerShell, but we're going to go in and configure that. We're going to say, you have this new RNDIS gadget. You're going to share your internet access with it. And then it's just at the bottom a little bit about ICS and how it works. It always uses the same subnet, the 192.168.137 block. I don't know why, but it'll keep everything in there, and it'll do a DHCP handout to the Armory as long as it's kept in there. So that was surprisingly seamless. And now there's a few things though that come as an issue when you try and do PowerShell. Namely the execution policy for PowerShell scripts. The default is going to be restricted. There's always some caveats there, but the short of it is our script is not going to run. Of course, when you have a keyboard and you can type and set whatever you want, that's not much of an issue, because we go in there and change it using set execution policy bypass. -force means no prompt, so it's easier. The one we're going to want to use is fourth option here, unrestricted. That means it runs anything. All signed just means they have to be signed. Ours obviously aren't, but with all those CAs getting compromised, who knows? Remote signed means only files, scripts from the web have to be signed, but safest option for us, just set it to unrestricted. And that makes it really easy for us to go ahead and run our PowerShell scripts. So how we actually make that change, I mentioned in the previous slide. We have this program called send file to HID. It works with string or files. But basically, once we have our HID keyboard device up, this program will use it, and we can give it a string, or we can give it a file, and it will type the whole thing out for us. So what we have to do is just these 3 lines to change the execution policy. Left meta, that's just a shorthand for the left Windows key. So that'll get that start menu open for us. PowerShell, and then carriage return, or a new line, will open up PowerShell for us. And lastly, we just use this little command, like I mentioned on the previous slide, to change the execution policy, which will allow, yes? If they're running as admin on the machine network. Even if it did, the HID device, the keyboard, can click through UAC files. Because, And that's kind of a larger issue. Like, the whole point of the UAC lockout is to lock out hostile software on the device from being able to get up in front of that window. But if it's a keyboard, UAC is gonna, it's a keyboard, so no trust issues there. Well, that's almost an unworkable scenario. Imagine a user takes a laptop home, and it's tough. Yeah, so for Richard, he's going to touch on a couple of mitigations at the end. So if you wouldn't mind holding for that, he's got a couple things to share on that. I haven't been able to think of many. I mean, if you start restricting what kind of USB peripherals users can plug in, you're asking for it. I mean, that's going to be a headache unless we start, putting digital certificates on all their keyboards. But we're going down a dark road there. So the only argument we call here is that is the actual HID device that was created. It's going to be under /dev/HIDG0. If it's your first one, increase numerically from there. Oh, yes. Admin. Local admin on the machine. Does that answer your question? Okay. So like I said, when we enable internet connection sharing, we do it with PowerShell. The script is kind of long. This is just kind of some pseudo of what we do. There's a DLL, that's the Home Network Configuration Manager. We have to load that in. Just do it once. It's a simple command, pretty easy. We have to instantiate a few things. We basically list out the network connections. We use some filtering to find the one we want, and then we make the necessary changes to turn ICS on right here from our script. And again, if we put the script, I wouldn't be able to read it. It'd be so small. So we'll just spare you from that. And then that's the process here. Similar to before, we want to actually run that script that sets up ICS. So same as before, left Windows key, get into PowerShell, and run our script. Now we're using a fixed drive letter here. Obviously, you don't know which drive letter is going to be mounted under. That's just how it works under Windows. You don't get to, the device doesn't get to specify a preference for drive letters, which is good because no one else uses drive letters anyway. So you could theoretically be mounted under any of the possible letters except probably C or D. But there are ways we can control the label. Like when you plug in the flash drive, it'll have a name, a label. We label ours Parasyste, and what we can do is we can actually go back into PowerShell if we have to, list out these gadgets, filter by label, find the one that's ours, and get the associated drive letter. But to shorten what's happening here, we'll just assume it's E, and we've already filtered it out and got it right there. And that's going to run our script and set ICS up for us. There's a few more screenshots of what that looks like. You'll see that's their network connection. We have sharing set up for local area connection 3. That's their Ethernet connection that they use for internet access. And here's what that looks like. Again, it puts everything in that 192.168.137 subnet. Don't know why. It's just the way ICS does it. So we work with it. At least it's predictable. That's one less thing we kind of have to script and be prepared for. So here's another little checkpoint of where we are so far. I've gone through those first 3. There's a few more items left, so I'm going to pass it back off to Richard, and he's going to talk about how we do reverse shell to our command and control.
Sure. All right, so at this point, technically we have internet access if we were on the device already, so I need to give myself access back to this device, right? So we've dropped it off, it's done all its gadget goodness, runs PowerShell scripts, it's on the host now. Now I want to get it to connect out because I've left the building now. I want to be able to connect to it. So this is just SSH goodness, right? So I'm not going to give you we're publishing the script to how to do reverse SSH, but I'm sure you've probably done that. So in this case, just a few of those settings that's there. So I send it to Amazon, but technically you can send it to any IP you want. Be an internal address, right? If the host can route to it, it will try to send it there. In my case, I expect probably 22 is allowed outbound. You can change that, right? I could change that port 22 to 443, so if you're not doing a little bit of protocol inspection, right, just make that whatever port you think can get out. All right, so I'm going to test your nerdiness. So does anybody recognize this number, 25641? What kind of number that is? If I had a giveaway, you would still get it. Good. So I'm the biggest nerd in here. So that's called a parasitic number. right? So I didn't even know that was a thing. I'm like, ooh, I need a number like associated with a parasite. What is that? So I just searched for parasite number. And that's a thing, right? So there's no mathematicians in here, I guess. So there's something called an in parasite number, which means in this case it's a 4 parasite number. And what that means is if you take the number 4 and you multiply it by this number, the 1 actually moves to the front. So the result is 102564. They call that an N parasitic number. This is a 4 parasitic number. Hello, Matt. So, you know, I'm a dork. So, in our case, we are doing key exchange through that. So I created a user, right, parasite. We created the associated SSH keys. I do have my authorized key file at Amazon, so I know it is only my device that's connected back to me. So that's just that. Auto SSH, we do use Auto SSH, and I stick this in a cron tab. So I expect that this is going to try to run. If it's ever not running, it fails, the computer reboots or something, it's going to try again, right? The parasite will automatically boot up the Linux host, or the Linux computer on that host will automatically boot up, right, when it gets powered to USB, and it's going to start trying to do that SSH. Just SSH goodness there. So now, right, I didn't think to show you a screenshot of SSH. That might not have been that exciting, but essentially this is the command. That top command is what I run from Amazon. So now I'm creating a tunnel, if you will, the reverse shell back through there. So I'll do this -w. It's connected to me at Amazon, so I will see a listening port for that 25641. So I'm just connecting to that port. It shows up as a local connection. I run that command and I'm connected back to it. And the only other thing I have to do is basically create a route. So there is some of those assumptions we're throwing out there that we should know your local host network. We can probably run some PowerShell and pump that too. We don't have any of that yet. So here I'm kind of assuming we know what that local network IP range is. That's something we'll have to get to. It's not there yet. And then with that, I can fully communicate with the host. So what we've done, right, we've plugged in the Armory. It's been recognized as a keyboard. It's been recognized as a network, a USB network device and storage on the host. It's run some commands. And again, it shows up on the screen. So, if you're sitting at the bank and the guy's got the back of his computer there and you plug it in, he's going to see stuff going on. So the other assumption, right, is they walked away from their PC, kind of plugged it there, and you left, or you walked away. So it's going to pop up the run menu. You can see PowerShell. PowerShell comes up, stuff's going on, right, and then it kind of goes away. It'll recognize those devices in the bottom corner. So whereas like the rubber ducky, I mean, they pride themselves on how fast they can run some of those hid commands. That's kind of all they can do is the hid commands. So I don't know what the time is on that. 20 seconds, right? You have to have them away from the keyboard for 20 seconds. This is probably more, maybe a minute, maybe not quite a minute, 45 seconds. I mean, it's still fast, right? So we plugged it in. We've done that. PowerShell's run. It's made a connection out to Amazon, and now we've connected back from Amazon. We are sitting on a Linux computer on the host. I can do all kinds of fun stuff. So just on some of the testing I've done. Honestly, I mean, we got pieces of this working, and then we finally shoved it all together, and we're like, yay, it's all working. So I couldn't do a ton of testing, but I tested all the things that I use all the time, right? Does Nmap work through this? So from Amazon, can I run Nmap on the local network? Yes, it works. Well, can I run Nexpose? So from Amazon, I've got a Nexpose instance. I actually scan the local host network. So you have to think through this, right? So I'm at Amazon. I've got Nexpose installed, my commercial tool. I run through this SSH tunnel, which essentially hits the device, and then it goes back out the device and scans the local network. And it appears to the local network that this desktop, right, the desktop IP MAC address is scanning the network. So that works. Nessus, the same thing, just different tool. Metasploit, and that works too. The only caveat there is when you're doing the payload handlers. So when you set that up, and I think you could figure through this, I just haven't done it yet. When you set up the payload handler, it's going to listen on the local interface. So it's going to listen on the Parasite, which is 192.168.137.2. And then you're going to send out a payload, and you're going to wait for that host to call back. right? And it's not going to know how to route back to a 192.168.137 network. The local network is not going to know that. So somehow we have to present ourselves as the desktop PC. I haven't figured out how to do that yet. Some of you might have some ideas. Telnet, SSH, SNMP, scanning across the network, touching those services. Any TCP service, pretty easy to do. RDP can actually do some commands to do remote desktops. So if you're connecting through that device to remote desktop on the host, obviously, any kind of web traffic. So protection. So every time we think of that would probably work, we think, well, we could probably get around it by that. So today there's not a lot of getting around. It's kind of, it just works. And I think in most cases this is going to work in a lot of instances. However, right, you get into where you could do some USB device control. You can stop storage from working. I suspect, I actually don't know, but I'm pretty sure you can stop RNDIS, right, at Ethernet USB. You should be able to control that through policy. That would kind of kill us, right, for any of that remote access. So that kind of stops us in our tracks there. Unless, right, we can find some kind of vulnerability that we could take advantage of, modify our stuff. The HID part, the keyboard, that's hard to control. I mean, it's, you're going to turn off USB keyboards. You're not going to do that. You can look at the VIDs and PIDs. So when we assign a device, it has a VID and a PID, and there's a special number associated with that. I mean, you can look up the ones we use. It's kind of a generic one that the rubber duckies and all those use. You can disable that, but we can change that, right? So it's pretty easy to change, but maybe it's effective for the low-hanging fruit. Better permissions. I get different results. So we could use help, you guys running this on different systems. Windows 7, Windows 10 worked pretty well. Every now and then the RNDIS driver wouldn't work on one. And then you try it again and then it worked fine. And then you try it again and it doesn't work. So I don't know if that's just Windows, right? What we're used to with Windows just doesn't quite work right. We are operating somewhat in context of the local administrator accounts. If you could disable those, maybe change your permissions there. I think we can get around that, so I almost hesitate to put that on there. Even with non-administrator permissions, most of this stuff works, so when I've seen it not work, I think it's something we're doing wrong. And then endpoint protection, we run some semantic endpoint protection, and it does kind of that network threat level monitoring, whatever you call that. It sees this traffic, and it said this is weird, unexpected network traffic, and so those killed that traffic. Again, but we could try to test and work around those, change IPs, do different things. So still to do. So we obviously need more testing. Windows 7, Windows 10 tested pretty well. I haven't even tried it on XP. Windows in general, haven't tried it on a lot of servers. I expect it's going to work fine on any of those, most of those, but I haven't tested it, so I can't tell you that for sure. We want to improve our scripts. We want to automate that a bit more. So now I'll show you the scripts we're going to publish out there. You have to manually kind of run those. You have to set that up. We want to basically build our own OS, so we're based on Debian or Kali, and we'll just build our stuff in there, and you just load the image on the Armory, and you're done. You're ready to go. So we want to make that stuff easier for you. Additional egress, so right now I'm just going out on port 22, and you can change that port, but we might want to tunnel that, so it's easy to tunnel things through maybe DNS type traffic or ICMP. DNS works pretty well. ICMP seems a little slow, but we can build that in there too. That's not that hard. We want to do more host exploitation. So again, I thought that is easy. We'll have everything done by the time this conference came. That host harvesting part, we haven't even really gotten to that yet. But we can dump past local hat. You're already there. You might as well. And you want to get your $130 device back. So while you're there, you might as well dump as much as you can from the host. Those are just some things we got to write. Haven't done that yet. And obviously, documentation guides, tutorials. If you're a nerd, you'll get this stuff right pretty quick. But we want to write that out and kind of bring it to the masses. And then Matthew, you want to talk about these?
Testing. All right. So regarding the Parasyste API, I'm sure you remember when I was talking about all of this. You create these files and you write the strings into these files, and you do all this manual file manipulation. Well, for the more program-minded people, you're probably thinking, this is so stupid, why can't I do this with an API? I mean, we can encapsulate all this very easily. And in fact, you can. There is one called libUSBG. If you've done USB development before, you're probably familiar with libUSB. libUSBG, the G is for gadgets, so it lets us do all this stuff with gadgets. So instead of going in and creating all these folders and writing stuff into all these files, you make a couple of API calls. You basically instantiate an object, call a few functions, and you're done. And we want to add even more functionality to that. Maybe provide some APIs, ways to hook in with like the issues he said with Metasploit. Maybe have some API hooks for different commonly used applications to give us some better integration there. Behavioral scripting. This is getting a little, not quite AI, but some basic decision making where, let's say, they try one of those things that would kind of block us, but it's trivial to get around if we want to, like they try and filter the vid in the PID. Well, vid and PID filtering, we can bring the device down, bring it up with a totally different vid and PID. It looks like a different device. That all takes about 3 seconds. So just the ability to kind of look at basic stumbling blocks, identify them, and then just make the little changes necessary like that to kind of get around them. Lastly, we want to make kind of just a single-purpose tool using HID and mass storage. And what we envision for this is basically a kind of one-click way to push a payload onto a target device. Or maybe, you know, if you don't want to run all the other stuff in a PowerShell, you know, and do all that, maybe you're just behind a computer and you just have a couple seconds when you want to put it in and do it. The idea for that is it'll mount your executable on the storage device. You'll plug it in, storage will mount, the keyboard will come up. The keyboard will do whatever it needs to do to run that executable. So your payload is deployed, and then it automatically unmounts, and then it's invisible again. Whole process takes a couple seconds. And we wanted, you know, especially if you're really on a time crunch and you just want to deploy a payload real quick, that's what we want to envision for the infect tool. So that's all for that. Do you have any closing?
Yep. So we want your help, right? So this is all working. It's good, but I mean, as you go through it, you're like, oh, it'd be cool if we did this. So, you know, we'd like some support, testing, help, all those things. So if it's something you're interested in, we created the website for it. There's really nothing there, but this is where we're going to dump everything. We have it as a private GitHub now, so we're going to make that a public GitHub. Probably first part of next week, we'll make that public. What you'll find there is what I'm just calling the gadget configuration script. So essentially, you can get Linux on there. You can buy the USB Armory. They've got documentation for how to get the Linux piece on there. Essentially, then there's just a script you run. So it's Linux, you run a script, and it sets up all the gadgets. We've got that, so we'll publish that out there. We might have a couple files for that the C program there, but that's basically the program that says, tell me what your strings or your program is that you want to send through that HID device. So it kind of just makes it so you can just type what you want to do, and then it sends it to the device. So we'll put that up there. That's our PowerShell script for enabling the ICS PowerShell script. And then if you want to do the reverse tunnel stuff, we'll have that shell script as well, and some instructions just on how to do that with the podcast. And we're right on 11:45, so if y'all have questions or you can find us out and about, thank you guys very much.